close. The only issue is, I don't know. Let's just see if it works. I don't know. If not, I'll Camtasiafy it. But it could also be that. Well, whatever. Let's see what happens. So I'm going to pull up Excel, and I'll make it a little bigger here so we can see it. Now, what we're going to do is a little exercise in Excel, so that after you've got your actual data, now you need to grab the equation and do an extrapolation or a prediction. So again, I'm just going to make up some data. It's not going to matter exactly what the numbers are, but here's time, and here's N for people, and here's C for carbon. Let's just take those three examples. So let's say you took some data at time 0, time 2, time 4, and time 6. And what you're actually looking for is like a prediction at time 60 days, about 2 months from now, or whatever you pick. Maybe it's 50, maybe it's 55, but it's going to be some number greater than where we started, right? Okay. So for N, I'm just going to make the number. Well, now I'll make the numbers big because they get a little gnarly, I think. So I'm going to put in 7,100,999,222, something like that. And for the next one, I'll put in 7,100,1,000,000. Yeah, let's go a little bigger than that. 102,500,000, 234. Let's do 7,104,400, whatever. Just kind of making these up. 7,106, comma 888, 234. Okay, so we can very easily, just with those numbers I just made up, insert, scatter plot, think. Okay, there it is. So there's kind of our fake data. Now we can do the same thing for carbon. Let's see. So I like doing the scatter. It's what's that? It does. I mean, I think you can pretty easily change it. Change series chart type, and there they are.
But the scatter just seems to work a little better.
Yeah. I mean, let's see what line is.
If I did mine in line, it'd take a
I don't think it's gonna. You're not gonna get any difference between scatter and line, really. Yeah. I don't think it's gonna matter in this case. Okay. So for carbon, let's just say, I don't know, 11, and this is gigatons basically, and I think we're at 30 plus gigatons per year, and we're a quarter of the way through the year. Maybe it's less than that. What's a reasonable number right now? 8 billion?
I forget what I was getting yesterday. It was,
my last
it seemed like it was close to the population, maybe a little bit higher.
8 or 9?
7 billion tons.
7 billion tons so far this year. Okay, so I'll start with like 7.5. We'll do 7.65, 7.79, 7, then like, I don't know, 8.1, something like that. So I could actually go in and just delete the whole chart, grab all three of these, and then do again, insert, scatter, think, done. Okay, now it looks a lot worse than it did before because I've like got way different units. So all I need to do, if I go down and click on I don't want to be 0.4, 0.0.
What if you just put the carbon in the same way you did the population and you just wrote in the 7 billion? Wrote it all the way out there.
No, what you want to do is what I just did. I want to put that data on the secondary axis. Did you see that?
But if you had wrote it out, all the way, like you do the population.
Yeah, I wouldn't.
Still work.
It would work, but I wouldn't. Don't do that. Don't put them on two separate axes.
Right.
But he's just saying having the number written out all the way over on that side, like 7.4.
Oh, I see what you're saying. Yeah, and you can even come in here. Look, if you do this, format axis, number, Yeah, I mean, you can put this guy in. Well, you can put it in scientific if you want, right? That's not looking all that great. Format axis. If we could do number, you know, I'd go ahead and put like 3 decimal points, something like that. It's not too bad. It's reasonable. And then over here, you know, to be consistent, you can do the same thing. Format axis. Throw in number, a couple data points. That's a little nicer, a little more consistent. Okay, so next thing we're going to do, click on that guy and just add trend line. I think you've probably gotten that far so far. We'll do linear, and what we're going to do is display the equation on the chart. So you've got to display the equation on the chart. Close.
Now, when we went to display equation,
Yep.
that just took the slope that's already there and put that in?
It did. Well, it took the slope and the y-intercept.
Okay.
So this,
So you didn't need to type that in at all?
I didn't type any of these numbers in.
Just put insert.
Insert trend line. Yeah, that's the power of computing.
Yeah.
Now, the one issue here is that we're going to want to format trend line label. We're going to turn it into a number, and I'm just going to throw a bunch of significant digits on there. Well, maybe not that many.
I figured out yesterday when I was doing this that that's what I did wrong last semester.
Oh.
I just had the 7 times 10 to the 9.
Yeah.
And it was, you know, my numbers seemed way lower than they should have been.
Oh.
I just realized yesterday when I formatted the label, I was like, oh, because that wasn't.
That's kind of why I
get all the numbers.
do this 2 semesters in a row, because it's tough to get right the first time. No, it really is. It really is. Okay, so this is, so X is actually T in days, so we can do, come over here. Format axis, number, axis options. No, it's not that. It's I just want to add a. Do you guys remember how to add an axis label?
I think you
if
click
you go
on
to,
the axis.
Not format axis. Oh, up here on the top, right?
go to design at the top,
Oh yeah, thanks. Design,
and then, or layout maybe,
layout,
and then you can add,
chart title, labels, axes,
Right by chart title. Axis title.
axis title. Primary horizontal axis title, final below axis. Okay. And then down here we would just say time T, and you put that in days. Okay. So that's kind of your first little linear chart. Now, really all I have to do from here, and I think I can do it for, let's just do it for both. Add trend line, make it linear, display equation, close. So we're seeing this again. We can just drag this guy down here, and there's probably enough significant digits to do this next one. So here's all we're going to do. So n equals, it just equals this equation. So it equals the slope, which is, and I'm doing this for n. So the slope is 978 346 times time, which is right here in days, plus 71007619113, which is the intercept. Okay, so that number is my prediction. I'll do a little control 1 on that number, 0 decimals, use comma separator, and you know, at first glance it looks pretty good, right? It's higher than the other numbers. Now, for let's do it again here just for clarity. So carbon equals, well, it equals the slope, which is 0.097 times, there's your time, plus 7.469. You're like, okay, well that's a big number, but I don't know, it was going up pretty quick, and in 60 days that might be right. So all you got to do from there, grab this whole guy again, copy, or no, grab it again, insert, scatter, dink. Have the same kind of issues we did a second ago, but I think if we format data series, secondary axis, close, cleans it up, and you're pretty much done. That's pretty much it. And so if you want in your summary to show both, that you're more than welcome to. The trend line, we can go ahead and add a trend line on this prediction, and it should go right through that extrapolated value. Let's just see here. Add trend line, linear. Let's not bother with the equation. Close. Yeah, like I said, it is right on that thing, and that's what it's supposed to do. It's going to take this line. You can see up in the first graph that we made that neither of those two trend lines really go through any of the data points. All it's trying to do is get the minimum error that it possibly can, and the error that it's getting is just really a little triangle. So if you think of this square right here as one of the vertices of a triangle, shoot out to the right until you hit the trend line, boom, that's your second vertice. Shoot down vertically, boom, there's your third vertex. That triangle has an area, right? So 1/2 VH squared. Do the same thing at each of the other points, boom, boom, boom. All it's doing is minimizing the area of those four triangles. And so it's just going to take that prediction, that line, and in the future, that's the prediction. It's the best linear fit you can do. Then you'll just repeat it for the exponential and the polynomial.
What's the you said parabolic and polynomial.
Okay, you want to do that one next?
Yeah, let's do that one.
Okay. Copy. Paste. So I'll do, here's linear. Here's poly. And here's exponential.
So you want to make a new sheet for each one?
It doesn't matter. You can put them on the same sheet, but I have the power. How do we do it on YouTube time? Let's see. I don't think a dang thing is recording.